discussing updates for SciPy. Not the conference, the library. It's also a library. So the way SciPy works, it's a huge monorepo of separate things. Unless you're a one-man army like Pali Virtanen, you don't know every detail of everything works, but try to keep informed. SciPy contains a lot of fundamental algorithms for numerical computing across a lot of domains, and we have some exciting updates. Recent highlights: free-threaded Python basic support. Python 3.13 is introducing free threading, where you have more granular locking instead of just having a global interpreter lock, the GIL over everything. Now, we don't have any benefits of parallelism, but SciPy is now thread safe. It can be used with Python 3.13 by just throwing locks over unset thread safe code, which is nice because you can try out Python free threaded without seg faulting and all kinds of things. There's a new top level module. How often does that happen? SciPy.differentiate offers tools for numerical differentiation of functions, first derivatives, of univariate functions, a Jacobian function for multivariate functions, vector to vector, and a Hessian function for second derivatives of arrays to scalar. Expanded array API support. This is exciting. Support for alternative backends, CuPy, JAX, PyTorch across different parts of the API. A new stats distribution infrastructure. I'll have more to say about that at 11:25 later on. Elementalized iterative methods. These are new tools, which are vectorized tools written in Python, which can eventually support alternative array API backends for root finding, integration, all kinds of things, differentiation. Sparse array improvements, sparse arrays. There used to be sparse matrix, now sparse array. 1D, 2D arrays, ND arrays for COO, coordinate array format. All kinds of new functions supported on sparse arrays. SciPy lineage, batch support. So parts of SciPy lineage have parameters, you can vectorize over arrays of arrays to do like array operations batch-wise over batches of arrays. It's very cool. Coming up, more PyTorch, CuPy, JAX support. The goal is to cover at least 70% of the public API, make actual use of free threading to use the parallelism and benefit from it, and simplifying building packaging through modernizing the code base. Getting rid of Fortran means that the builds become super easy, and it's Fortran is cool, but it just doesn't mix well with the C Python ecosystem. So yeah, and join the conversation. Here's this. Thanks, everyone.
Please welcome the incomparable Draga Doncilla Pop for Napari.
I don't know if I'm incomparable, but we'll go with it. So hi, I'm Draga. I'm one of the core team members for Napari, and if you don't know what Napari is, there's kind of a good GIF of it there. It is a viewer for n-dimensional data, so 2D data, 3D data, and more dimensions as well. Some recent highlights since we last spoke to you at SciPy last year. We've got a lot of exciting new features. There's a command palette if you never want to leave the keyboard. We've got really fast polygons, and we've got polygons with holes in them. There's configurable viewer handedness, so there's more flexibility in how we display your data in the canvas. Lots of UI enhancements, and on the right there, you can see true grid mode is what we call it, which allows you to manipulate all of your images, all of your layers in a grid. Napari is not just the core viewer, though. We've got a really rich plugin ecosystem. There's over 500 community-built plugins for Napari that allow you to read different file formats, extend the UI, and perform domain-specific analyses. You can install these plugins directly from the viewer, or we now have a new community-run and developed website for browsing plugins and discovering plugins that can can suit your needs. We also have a new development roadmap, which we posted to social media yesterday, not just because we had this tool talk. There's a lot of technical features on it. We're looking at implementing multiple canvases, unifying the application model, which is going to be really important for serializing the viewer. And we're looking at improving the plugin manifest design so that you can contribute to the viewer via plugins in more interesting ways. We've been making regular releases, and we're committed to continuing that over the next year. We're going to be trialing new ways to support our community with like office drop-in hours and training workshops. And if you were at our tutorial on Tuesday, you'll know that we love to teach Napari. And we're looking at streamlining the contributor process as well, so that if you do come and join the team, we make it a joyful and pleasant experience for you. Speaking of the team, there are 3 new core team members this year. On the West Coast, we've got Ashley Anderson, who despite appearances is not a cactus. Filling up the middle of the US, we've got Tim Monco, who is our new community manager. And we're very privileged to have just welcomed Carol Willing to the core team, which is going to be, yeah. That's clapping for us because we managed to grab her. So yeah, these new contributors had just joined the team this year, and we're super excited to have them, along other many contributors, but these are the core team members that we've added. And if you want to join us as well, please do. There's our links. 4 of us are going to be at the sprints. So yeah, come join us and contribute to Napari. Thank you.
Thank you, Draga. Let's hear it for Tetsuro Koyama and PyVista. Oh, it's a team. Sorry.
So, hello everybody. I'm not Tetsu. I'm Bane Sullivan, and I'm one of the creators of PyVista. So PyVista is all about making 3D visualization and analytics more approachable to domain scientists, making it so you don't have to know all of the nuances of computer graphics and 3D visualization, and like take this really powerful and sophisticated 3D visualization library called VTK, the Visualization Toolkit, and take like the 20 lines of code it is to just plot something and make it 2 lines of code. Load your mesh and then just plot it. And so, yeah, who is PyVista for? It really is for any domain scientist, whether if you're working with any sort of spatial data, so things that are meshes and volumes. Doesn't matter if you're trying to do cartographic rendering of oceanic data sets across the globe, or if you're looking at CFD simulations of electronics components, medical imaging, aeronautical engineering. We have developers and users from just about all walks of science and engineering. And so PyVista provides these 3D spatial data structures in addition to the visualization. It gives you like a mechanism for managing your data and working with it, applying transformations to it. It has a Pythonic API that's meant to be used if you're comfortable in the Python data science stack. So yeah, so where are we? We had our first release in 2019. We've had just an immense amount of growth and progress. We have over 190 contributors these days. Our latest release this year had some big improvements, getting us up to speed with NumPy 2.0 and Python 3.13, supporting the latest versions of VTK, and lots of great improvements around volume rendering, new filters, tons and tons of contributors, or new features from community contributors. So what's next? I don't really know. The biggest remaining challenges are around big data handling. Our answer, if you want to render a big data set, is get a bigger computer or bigger GPU, and that's pretty unacceptable. We live in the age of big data and cloud-optimized data formats, so we should be able to support those. So these are really big challenges that I think 3D visualization across the board still faces. And then just more stuff on the web. We support running PyVista on the web. There are websites powered by PyVista with 3D visualization front and center, but it's just frankly not good enough for me yet. And then just sharing your work and sharing and collaborating. The age of sending screenshots back and forth over email should be over. It should be dead. And then, yeah, so just if you're interested in learning about PyVista, if you work with 3D data, go check out our tutorial at tutorial.pyvista.org. We work really, really hard to make contributing as seamless as possible. If there's new ways you want to analyze or visualize your data, get involved on GitHub, join us there, and help us solve these big challenges around big data and more web and collaboration. Thank you.
Appreciate it. Okay, next up we have SciPy and QDF, Leo Fang and V.S. Ramasubramani. Thank you, gentlemen. Come on up.
Awesome. Hey everyone. I will go through this fast. This is Leo. I'm VS. Thanks for being here. For those of you who aren't familiar with us, QDF is basically meant to be pandas on the GPU, or at least that's how we've talked about ourselves for quite a long time. Hopefully a few of you saw my talk yesterday, so you'll know that our first sort of biggest new thing, well, okay, actually I should start with this. For those of you who were here last year and have not tried us too much since, all of QDF is now available on PyPI proper. It's a nice big step for us. So just go ahead and pip install us, and it's very easy. These slides seem to be slightly out of order. For those of you who saw my talk yesterday, our big announcement since last year is that we now also support polars. So if you use polars today, try us out. All you got to do is, like I have up there, type in engine equals GPU, and you'll run on the GPU. As part of this effort, we've put out a new library, PyLibQDF, which is a really, really high-performance, low-level GPU data frame library. So if you're really seeking peak performance, you can try that out. Instead of the overhead of looking like pandas or like polars, you get something fast as possible. QDF, our core library. Couple major improvements. We now support large string data, we scale better, and we support rolling operations at a much faster speed than we used to. And then our zero code change acceleration for pandas. The major thing is, again, larger than memory workloads are now supported, and we work really transparently with NumPy now. And with that, I'll hand off to Leo.
All right, thank you, Vias, and thank you for having me here. I'm Leo Fang. I'm CUDA Python tech lead here. So I'm today here talking about SciPy, and SciPy used to be a drop-in replacement for NumPy on GPUs. But with recent SciPy evolvements, we are proud to announce that we have substantial coverage over NumPy and SciPy APIs, plus new NumPy-like kernel authoring for NVIDIA GPUs. So you can treat it like a collection of different packages to target NVIDIA GPUs. And the latest release is 13.5.1, just came out in the midnight, and it supports CUDA 11 and 12. So this is a number like kernel authoring that SciPy supports. You can write Python syntax, and you write your own kernels to target on GPUs, and it will run seamlessly. And behind the hood, I explained in my Wednesday talk how the black magic happened. So if you are interested, you can watch the recording. So another thing that's new in 13.5 is this new unified memory programming thing. So for certain hardwares, there is a unified memory stuff going on, and SciPy has added experimental support for you to unify the memory space and use NumPy and SciPy. Use NumPy and SciPy to write to set the execution space, and give it a try and let us know how it goes. Thank you. The slide's done.
Okay, next, the great Cam Gerlach on Spider. Take it away, Cam.
Alrighty. Hey everybody, this is Cam with Spider, the scientific Python programming, wow, I messed up the first line. The scientific Python development environment. So, first of all, the biggest news we've had for the past year, Spider 6 was released. So, just a quick review of the features. The first release of our remote development platform, which makes it much easier to develop on remote machines with Spider. Our new Conda-based installers make installation and especially updating a lot easier. A new debugger pane, which includes a stack frame browser, so you can jump through the various layers of your tracebacks. And then also a much faster search feature for project files, so you can quickly find the file you're looking for, and a number of UI and UX improvements. So, somehow my slides are messed up. Okay, I don't know what's going on there. I'm just going to roll with it. So overall status, so Spider 6.0.x is our current stable branch. bug compatibility fixes, while Spider 6.1 is coming out in late August, and with Alpha 3 already out, so we're on track for a release around that time frame. So that's our next feature release. So in 6.0.x, we've had 7 patch releases, support for nested progress bars in your consoles, improved accessibility for traceback, which is really important, a number of fixes to the whole debugger system, and I mean, kind of a little bit more of an accomplishment here. We've had, just for our standalone installers alone, we've had about 500,000 updates and downloads per month, which is quite big since they're a brand new platform for us. So very looking forward there. Also, we have a new support Spider page. So if you're interested in donating to specific features for Spider and you want to get them implemented, that's where you can do that. And now let's look at what's coming in Spider 6.1, which is our next major feature release. We have our remote file pane, which allows you to actually not only browse, but actually edit files, upload and download as well remotely. And we also have our Jupyter Hub integration, so that allows you to connect to any Jupyter Hub instance. We have our new, my favorite feature, our new environment and package manager built into Spider, so you can manage packages with actually using Pixie as the backend, so it supports PyPI and Conda, all using Pixie, which is great, and it's all under the hood. And it also works locally and remotely, which is really cool on installing things on remote machines as well. There's also a graphical updater for the standalone installers, which makes things a lot friendlier and easier to use. And looks like my slides were spliced a little bit here, but and also very highly awaited. It was multi-line editing support, so you can have multiple cursors in columns or in different places. Very highly requested over the past few years, and especially at last SciPy. And so now looking forward for next year for Spider 6.2, we've got remote editing, remote terminals, remote projects, also much faster code search with ripgrep using with Rust, and also a number of performance improvements to the editor to make Spider a lot snappier for you. So that's all I have for you now. But if you want to hear more and actually see a live demo of these remote development and project and package installation features in action, you can come to our talk later today in room 317 at 2:35. And until then, happy spidering.
Thanks for that tour de force, Cam. And next we have, I don't know what happened to those slides. Sorry about that. Here's Jupyter Hub. Look great? Good. We have 4 presenters from Jupyter in 3 minutes. Matthew, if I could ask you to have the call standing by. We have Martha Cryan, UV Panda, Angus Hollins, and David Q. Bring it in.
All right, we have a lot of updates, so we're going to go fast. First, we're talking about the governance changes. We recently transitioned to the Linux Foundation and launched the Jupyter Foundation. There's also a couple of new executive council members. Chris Holdgraf and Rick Wagner are replacing Fernando Perez and Brian Granger. And we just want to really thank Brian and Fernando for everything they've done for this project. If you have questions about this transition for the Executive Council, they are holding an AMA today on Zoom from noon to 1:30. So you can follow that link for the Zoom.
Jupyter Hub still is a very active project, lots of new releases, go check it out. I also want to remind everyone that Jupyter Hub is more than just Jupyter Lab or Jupyter Notebooks. It supports all web applications, RStudio, VS Code, SSH. So please think about that when you're using it. How many of you have given up on using mybinder.org because it spins and doesn't work? We've made a lot of structural improvements in the last 6 months. It's getting better. Please come back and try again and report issues to the Jupyter Zulip.
Hi everyone, JupyterBook 2, we've just released our 2.0 beta. We're now on a new document engine, very exciting. Some new features include things like bringing your own binder in Jupyter Hub, richer cross-project sharing. You can quickly see your changes as you edit with a live edit loop. And of course, if you want to upgrade, you just run JupyterBook. Thank you.
Hi everybody, we're very excited to announce that Jupyter AI v3 is almost complete. So Jupyter AI v2 only allowed a single language model and a single chat. Jupyter AI v3 will allow for multiple agents and multiple chats using any agentic framework of choice. So as a proof of concept, we already have Claude code working in Jupyter Lab, and we're really hoping to release that very soon. Thank you.
Yeah.
I'm flattered.
Oh, that's cool. Yeah, we have a couple of events to plug. JupyterCon is happening in San Diego, November 3rd through 5th, and we just extended the call for proposals. It ends July 20th, so get your proposals in. We're also about to launch the call for proposals for a new round of Jupyter workshops. So you can check our blog to see when that comes out. And finally, we just wanted to point out that we have Zulip now, and it's improved. The interface has improved if you had a similar thing to my binder. And we have a bunch of different links here for different ways to contact Jupyter. So come find us. Yeah, thank you so much.
Under 3 minutes.
A comfortable 12 seconds to spare for that team. Well done. Akshay Agrawal is up next with Marina.
Hey everyone, I'm Akshay. I lead the team behind Marimo. Marimo is an open source reactive Python notebook, and we like to think of it as blending interactive computing with the reproducibility and reusability of software. In some senses, it's a new kind of notebook. It's reactive, which means that the code on the page matches the outputs you see, so we try to eliminate hidden state. It's reproducible in execution and in packaging. It's actually stored as a Python script by default, so you can version it with Git easily, you can run it as a script, you can reuse modules, reuse them as modules for functions and classes, just import them straight into another notebook or a Python file. And it has interactive elements built in, so you can share Marimo notebooks as web apps, running on a server or entirely in the browser with WebAssembly. We've built Marimo entirely from scratch, so there's no dependencies on Jupyter or IPython. So what does reactive execution mean? Well, it means something like this. If you change a cell and run it, all other cells that depend on the variables defined by that cell run automatically. So that eliminates hidden state. Some of you guys may be thinking, oh, but my notebooks are expensive. I don't want things to automatically calculate. In that case, Marimo has a lazy executor. You can configure it to just mark cells as stale while still giving you guarantees on state. We have interactive elements built in, and you can build dynamic sort of interactive experiences with no callbacks. You import Marimo as Mo into your notebook, and you get a whole lot of sort of UI elements. We have pretty strong adoption. Marimo was launched just last year after being incubated with scientists at Stanford Slack. A lot of folks are using us now. We have over 300,000 monthly downloads on SciPy, over 14,000 GitHub stars. And we have a very strong contributor community, and we really welcome contributions. We have over 150 contributors on GitHub today. So we have a lot of project updates since last year. Here are just some. So we have a built-in package management solution. You can manage dependencies from the notebook UI using UV or using pip or using Pixie or even Rye, your favorite package manager. We have sandbox notebooks, which give you some reproducibility in packaging. And we can actually automatically track the dependencies that your notebook uses in the notebook file and run your notebook in an isolated env to give you sort of fully reproducible notebooks. We have interactive data frame viewers, native SQL support. We've standardized on any widget for third-party UI widgets, and a whole lot more that you can check out in our docs if you like. So this is what our package manager panel looks like. This view was actually contributed by Trevor Mans, who is now part of the Marimo team. We have some cool new interactive explorers for working with data frames in Marimo notebooks. We're working towards a native VS Code extension, data pipelines, more agentic AI assistance. We have a talk later today. Please come check it out at 1:55 p.m. Thank you.
Great. Finally, bringing us home for the day, it's Gil Forsyth on IBIS. Did you draw that yourself?
No, Patrick drew that. Thank you, Patrick. So IBIS is the 100% portable Python data frame library. It's just an interface. It's not an engine. We give you the interface. You bring the engine. So what that means is that you can write Pythonic, consistent data frame code, but then if you, say, work at a large enterprise and you have many different data sources, you don't have to switch tools. Or if you work at an academic institution and you have many different data sources, you don't have to switch tools. So it's handy. You should try it out. What's new? We've added support for Athena and Databricks. That is an 11% increase in backends. There's been a 90% reduction in full-time developers, but we're still going strong, and there's been a corresponding uptick in community contributions. We now have integration with Kedro, thanks to Deepimon for that, and also new support in Pandera, which is really exciting because if you need to do a bunch of data validation, you don't need to just do that in memory anymore. You can run something very, very quickly over, say, like 100 million rows in a SQL database, and it'll just work. Having said that, you can find us on the internet here, on the web, on Zulip, on LinkedIn, I guess. And then if you're using one of Athena, BigQuery, ClickHouse, Databricks, DataFusion, Druid, DuckDB, Exasolve, Link, Impala, MySQL, MySQL, Oracle, Polars, Postgres, PySpark, ResumeWave, Snowflake, SQLite, or Trino, you can try us out. Thanks so much.
That was it. Thank you for all the maintainers for preparing that material. Please enjoy a break until the next session begins at 10:45. Thanks again.